Rely on Bic Crystal, the long-lasting pen with perfect ink flow.
Buli muzadde yandyagadde okutwala omwana we mu ssomero erigenda okumuwa omusingi gw'ebyenjigiriza ebyesigamiziddwa ku ddiini n'empisa era nga bino ogenda kubisanga mu kifo kimu kyokka mu masomero ga Kinawa Schools. Amasomero gaffe gano gonna g'abawala n'abalenzi omuli abadde ne boarding gano nga gali ku musingi gwa busiraamu era nga galina branches ziwerera ddala 3 omuli ey'Ekawempe, Kasangati ne Kyengera Mugongo Zone. Amasomero gano gonna galina compound ezirabika obulungi ate nga mpeweevu. Tutumbula ebitone by'abayizi okuyita mu by'emizannyo, okuyimba ssaako ne katemba. Mwana tu abayizi baffe bayitira ddala bulungi nnyo anti tulina buli kimu kye beetaaga omuli science laboratory, library ejjudde obulungi, computer lab ssaako n'abasomesa abakuguka mu kubangula abayizi. Ebisulo byaffe bya mulembe nnyo so nga ate n'ebisale bijja mu buli nsawo ya muzadde. Kati nno ggwe omuzadde kola ensalawo egenda okuteeka ettaffaali ku biseera by'omwana we eby'omu maaso. Muleete ku Kinawa Schools tutuukirire kati ku matabi gaffe omuli ery'Ekawempe, Kasangati ne Kyengera Mugongo Zone oba otukubire ku nnamba z'essimu ezowammanga.
Okwewala oba okwekuuma akawuka ka COVID-19 akalumya ensi yonna. Bino wammanga byolina okukola okuziyiza okusaasaana kw'akawuka kano aka COVID-19. Naaba engalo ng'okozesa amazzi ne sabbuuni buli kadde. Weewala okubeera mu bantu abangi buli w'obeera. Weewala okukwata mu maaso, ku nnyindo, ku mumwa n'engalo nga si nnyonjo. Kolola oba nyiza mu nsonda y'akakokolako oba okozesa akatambaala bw'omaliriza okasuule mu dustibin yo. Bw'ofuna obubonero obulaga COVID-19 sigala ewaka okubire aba Ministry of Health ku 0800 oba ku 0800 okufuna obuyambi. Wabula bw'oba oyagala kuzza bujja intaneti yo eya Rock Telecom, kozesa emikutu gyaffe egya digito nga Mastercard, Visa ne ba agent. Osobola okunyiga *252#, sigala ewaka, sigala nga weekuumye, sigala ku Rock Internet.
Rock Telecom.
Green Hill Academy has high standards of learning and the teachers are very good. They give you a sense of belonging.
Green Hill has helped me to discover my talent.
The environment is good.
Encouraged us children to be excellent in our academics, in sports.
It's taught me how to be responsible.
Green Hill Academy helps us
because it's diverse. You can do the sports, you can do the singing.
They are the reason why I'm who I am.
Because in 2016 I was the overall national debate champion.
Many people may be confused and wondering, if I have flu and cough, does it mean I have COVID? Not necessarily, because COVID is caused by a coronavirus, and we've had coronaviruses before. But we have been giving you the signs and symptoms. If you have flu, you have cough, you have a fever, and the cough is a dry, irritating cough, you may have COVID. Call our toll-free line, 919. You will be responded to and clearly explain the signs and symptoms that you have so that we can quickly analyze the alert and respond accordingly.
PBS, terefayina eyaffe.
Somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisulo eby'omulembe, science laboratory ssaako ne computer lab wamu ne.
She gives you her number, but your pen didn't work and the bus is gone. Get a pen you can rely on Bic Crystal, the long-lasting pen with perfect ink flow.
Wamune.
Green Hill Academy has high standards of learning and the teachers are very good. They give you a sense of belonging.
Green Hill has helped me to discover my talent.
The environment is good.
Encouraged us children to be excellent.
Wamune.
Kids Kingdom Kindergarten and Daycare. Somero ly'abaana bato omuzadde leeta omwana ogenda okola ebibyo ebyokuzanyisa by'abaana byonna mu nsi tubirina ate nga abaana we bazannyira wagazi nnyo jjukira security enka amasomero gonna gali mu kikomera abasomesa be tulina bakugu mu baana abaana tubaliisa bulungi nnyo munnange tulina main campus e Buddo Naggalabi nga bwakayisa Buddo Junior.
Kale eddakiika zitambudde tulondooza ku ssaawa essaawa ennya tuyiseeko eddakiika nga 11 ate twagala kuba tutandikirawo senior 4 chemistry gwe tugenda mu kaseera kano kennyini n'olwekyo gwe omuyizi wa senior 4 senior 5 tuula nawa senior 3 tuula bino byonna osobola okuba nga obigoberera bulungi nnyo. Kale sigenda kulwisawo engeri akadde gye katambudde tugende mu kiraasi tusome ebirala tunaabinyumya edda.
Our dear viewers, good morning. Once again, we are meeting for chemistry and we are still covering mole concept. And I pray by the end of today and next week, mole concept will be done. I don't want to waste a lot of time because we have a few minutes left. Let me begin off. We are still covering mole concept. And last week, we looked at molar gas volumes. And in molar gas volumes, I left you with some numbers, but before we hinted on molar gas volumes, we had seen some numbers on what of crystallization. I left you with some numbers. I'm going to be a bit fast because I want to cover a lot today. So the number I left you, number 1, had a crystalline solid which had a chemical formula of Q. That was its chemical formula. And they also gave you its water of crystallization was given in percentage, and it was 51.2%. And they said, in our question, they said the rest composition by mass was being occupied by Q. Therefore, percentage composition of Q would be calculated as, remember this is given in percentage, and we said that whenever these compositions are given in percentages, they must always sum up to 100. Therefore, we shall have 100 minus what? Minus 51.2. And what do we get? We get 48.8%. I've not written the word percent, the symbol percentage this side because I've already represented it this side. Therefore, the other steps would be normal, whereby we would have our compounds, and our compounds were in that hydrated salt. We have Q. We also have our water of crystallization. Our percentage composition by mass we have already calculated for the one for Q, which is 48.8, and this was 51.2. Therefore, we are supposed to go to the next step, which is number of moles. I'm hurrying a bit. which is going to be our 48 given mass over our relative molecular mass. Remember, they gave us Q to be 120. Therefore, we divide by 120. They also gave us the relative atomic mass for hydrogen to be 1 and the one for oxygen to be 16. I told you, don't just impart it there. You must show it to the examiner, whereby you will go back and calculate for the formula mass for water. But it is what? 18. Then you get the number of moles. The number of moles, 48.8 divide by 120. And what do you get? You get 0.0. Let me take it to 4 decimal places to reduce on the errors. Then I'll have 51.2 divide by 18. And what do I get? I also get 2.8444. I'm taking it also to 4 decimal places. Then I'll look for my mole. My mole ratio, which is, I write back my number of moles divide by the smallest. Also here, divide by the smallest. This automatically gives me 1, and therefore dot dot, that is the ratio sign, 2.844 divide by, and what do I get? I get 6.999, which I approximate to what? To 7. Therefore, my mole ratio for that compound, for those compounds, is going to be, this is my Q, this is for my water of crystallization. This is 1 to 7. And remember that the question wanted only us to find the value for our, remember this was our chemical formula. The question only wanted the value for X. And therefore, I told you people that what corresponds to the number of moles, the figure that corresponds to the number of moles for water of crystallization will be the number of moles of water of crystallization. Therefore, our X was 7. And if the question had gone further to ask to deduce, to tell to deduce the chemical formula, then it would be simply our Q dot 7 water. And that was the first number I left you with. And I hope guys there, the viewers there, the students there, had to do it that way. Taking interest here, please, any value you're going to use, unless it has been given to you by the examiner, you must always show the examiner where such a value is coming from. That's why I said here, we know it that it's 18. But the examiner does not know it, that it is 18. Therefore, you must calculate for the molecular mass or the molar mass of water. That was our example, our number 1. Number 2, it was on what we covered basically last week, which was on molar gas volume, whereby they gave you glucose, and the CDR4s, you've met this in biology, you're also meeting it. Okay? You're also meeting it now in chemistry. Plus our energy. Remember, this is an exothermic reaction. We balance it, and then balance it. Our dear viewers, please, 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 I repeat, in chemistry, 3/4 of your paper 2 will necessitate you to state the observation and also to write the chemical equations. However smart your chemical equations may be, as long as they are not balanced, as long as the chemical symbols are wrong, you'll be wasting time. We shall only maybe penalize you a bit. Penalize you a bit if you've only forgotten state symbols. But in case the chemical symbols or chemical formulae are wrong and the equation is not balanced, you would be wasting time. Please take note of that. So this is what they gave you, and I remember they gave you to calculate for the volume of carbon dioxide gas that would be evolved if glucose was completely burnt in oxygen. And they gave you the mass for glucose. They said what mass would be evolved if 4.6 grams of glucose was completely burnt in oxygen. I remember, once your equation is balanced, you have to write it back for the examiner to really show the examiner that you know what you're doing. Therefore, here you're really seeing that there is 1. Therefore, we shall say 1 mole of glucose reacts with one mole of what? Reacts with 6 moles of oxygen to form or to form 6 moles. 6 moles of carbon dioxide and 6 moles of water. This statement is very vital. There are cases whereby the marks allocated to this question are too many, whereby this question will be scored either half a mark or a full mark. Therefore, please write this statement. That statement, always don't forget it. Once your equation is balanced, this statement will tell it all. Therefore, remember they gave us how many grams? They gave us 6.4 grams. But they're asking for carbon dioxide. It means that our calculations will be in terms of glucose and in terms of carbon dioxide. But they gave you a hint that 1 mole of a gas, they wanted our mole of gas, our 1 mole of gas. Therefore, we shall say, but 1 mole of a gas that was at STP occupies 2 centimeters cubed. It means that our volume for carbon dioxide was to be measured at STP, but again measured in centimeters cubed. But our glucose was given in grams, and therefore what comes into your mind? That you must look for a way of changing the 1 mole of glucose into grams by looking for its molar mass. Therefore, molar mass of glucose it will be 1 times carbon, but times what? Times 6. Plus what? 1 times H, but times 12. This would be 1 times O, but times 6. This is 1 times 12 times 6, plus 1 times 1 times 12, plus 1 times 16 times 6. What is this? This is 72, this is 12, and this is going to be 96. What do we get? Don't forget the role of this calculator. Some of you tend to WISEC, and then when it comes to summing up, you get wrong values. So you get 180 grams. That is its molar mass. We go back to our question. This time around, we shall not write back all what was in our first statement. We shall only now be looking at glucose and then our carbon dioxide. Therefore, we shall say 180 grams of glucose evolves. Why does it evolve? It evolves 6 moles. It evolves 6 times what? Remember we said our 1 mole of a gas at STP, it was in centimeters cubed. That's what it evolves. But remember we are saying of carbon dioxide. Remember we are saying all our calculations must be from first principles. Therefore, we shall ask ourselves, what about the 4.6 grams of glucose? When completely burnt, what will they evolve? They will evolve 224 times 6 over 180 grams times the 4.6 grams. This was in centimeters cubed. And what answer do you get? I know our dear students, you've tried this out. You're only checking to see whether you are at par. So we shall have 22 times 6 divide by 180. Okay? Times 4.6. 224 times 6 times 4.6 divide by 180 grams. And what do you get? Our volume for carbon dioxide is 3.67 centimeters cubed. And that is the answer you were supposed to get. After looking at this, I want to summarize a bit of what we looked at last week, that was on molar gas volume. Please, I told you, only and only remember how many statements? 2 statements. 1 mole of a gas at STP, what does it occupy? It occupies 22.4 decimeters cubed, or 22.4 liters, or 22,400 centimeters cubed. You must also remember, what about at room temperature? 1 mole of a gas, whatever the gas is, 1 mole of a gas at room temperature will occupy either 24 liters or 24 decimeters cubed or 24,000 centimeters cubed. and that will mark the end of molar gas volumes. I'll leave you with more numbers, don't worry. But remember, all the calculations you're doing, that is in paper 1 and your practical paper, should be from first principles. In paper 1, you may risk, but in paper 2, paper 3, or paper 4, they should be from first principles. Let us look at what we are supposed to cover today. That is what we are covering today. Gay-Lussa's law. One would be wondering, again, we are meeting laws in chemistry, like any other discipline. Chemistry also has some laws, and one of the laws that we shall meet in mole concept is the Gay-Lussa's law. The Gay-Lussa's law will only deal with those chemical reactions that are only dealing with gases. What does that mean? The reactants and the products are both in gaseous state. So in Gay-Lussa's law, we shall only look at chemical reactions that only involve gases. What does this law state? This law states that the law states that when gases react or combine, comma, they do so in volumes that bear simple or simpler ratios. Let me use that. That bear simpler ratios to one another and to their gaseous products, provided pressure and temperature remain constant, or pressure and temperature are the same. So what does this law state? This law states that when gases combine, they will do so in volumes that bear simpler ratios to one another and to their gaseous products, provided they are measured under the same conditions of pressure and temperature. In Gay-Lussa's law, you will be given gases. I began by saying it only deals with chemical reactions whereby only gases are involved. The reactants and products are both in gaseous state. And here we shall not meet at STP, at room temperature. We shall not meet that. But we shall only use the mole ratios and then the volumes to get what the question wants us to do. For example, if I have the commonest, I have hydrogen gas being reacted with oxygen to give me water, vapor. Okay? And I told you my symbols are correctly written. But I told you in chemistry, in paper 2, paper 3, paper 1, once these equations are not balanced, you'd be wasting time. Therefore, let us try to balance. We have 2 oxygen atoms this side, we only have 1 this side. Therefore, we multiply her with a what? With a 2. And when you do so, it has affected the number of hydrogen atoms. Therefore, we multiply her with what? 2. So from our equation, what do we see? We see that 2 moles of hydrogen, okay, react with 1 mole of oxygen to form what? To form 2 moles of water vapor. Okay? But remember, from our law is saying that when gases do react, what do? They do so in volumes. It means that now the moles are equated to volume. What does that mean? This same statement is the same as saying there are 2 volumes of hydrogen gas, okay, react with 1 volume of oxygen to form 2 volumes of water vapor. Okay? So because that is what our law is saying, when gases combined, they do so in volumes that bear simpler ratios to one another and to the product of the gaseous product. What does that mean? You're seeing, indeed, there are simpler ratios. This is the 2 to 1, and then this is the gaseous product formed, which is water vapor. But it is also a simpler ratio. It is a simple ratio to one of the to one of the moles, or to the one of the numbers of the reactants. That's what the law states. The moles are converted into volume. That is what our statement is trying to mean. Therefore, any question can be asked, whereby they may ask for the volume of water vapor formed. They give you volumes for maybe for hydrogen, or they give you the volume for oxygen. And here I always tell my students, here you have to use a bit, or you must be a bit logical, because sometimes the values given to you need you to think that if I start with this, according to my equation, does it really give me that? Let us look at example 1. Let me hope you have copied down this. Let me hope you have copied down what the law states. You never know. They may ask you. They may begin by writing for you the chemical equation. They ask you what Gay-Lussa's law states, and then the questions may follow. So let me hope you have copied down that. Okay. Let us continue. Okay. They may begin by saying, okay, they may begin by saying, okay, 20 centimeters cubed of hydrogen gas was mixed with 5 centimeters cubed of oxygen and water vapor was formed. That is my question 1 on Gay-Lussa's law. So if it is paper 1, they will write for you the equation. But if it is paper 2, they will ask you to write the equation, whether you want it or you don't want it. And failure to write the equation, it means that you will not continue. Therefore, we shall start by writing our equation. And our equation, we are having hydrogen gas. Remember, hydrogen is diatomic. Oxygen is also diatomic. Giving us what? Giving us water. Water vapor. Okay? We balance our equation by simply multiplying here with a 2, by multiplying here with also a 2. Therefore, from our equation, what does that mean? 2 volumes of hydrogen gas react with 1 volume of oxygen to give us 2 volumes of water vapor. But what does the question want? They're asking for the volume of unreacted. They're asking for the volume of water vapor that was formed. The volume of water vapor that was formed. What do you see? You're seeing that 2 volumes of hydrogen evolve also 2 volumes of what? 2 volumes of water vapor. Therefore, volume of water vapor, volume of water vapor, okay? What will the volume of water vapor be? The volume of water vapor will be equal to the volume of hydrogen gas. Or, remember from our mole ratio, it means that twice the volume of oxygen will also give us the volume of what? Water vapor. Therefore, or the volume of water vapor will equal to twice the volume, 2 times the volume of oxygen gas. That is from our equation. And once you know, this is where you have to put the logic I was talking about. This is where you have to use your logic. That is our equation. Okay? If you start by using this, if you start by using 20 centimeters cube, it means that the 2 volumes are occupying what? 20 centimeters cubed. What will then the volume of oxygen be? It is going to be a half the volume of what? Of water, sorry, of hydrogen, which is going to be 10 centimeters what? Cubed. And automatically, this will also be 20 centimeters cubed. If you follow this. But remember, our question is saying 20 centimeters cubed of hydrogen was mixed with 5 centimeters cubed of oxygen. It means that what is that volume of oxygen that reacted? It means that the volume of oxygen that reacted was 5 centimeters what? Cubed. But according to our equation, our reaction equation, it is 10. It means that even if they gave you all this 20 for hydrogen, not all of it did what? Reacted. Therefore, then we reverse. How shall we reverse? We are going to reverse so that our values fit in what we are given. How are we going to reverse it? By saying now, if this is 5, centimeters cubed. Then automatically this is going to be what? 10 centimeters cubed, because the volume of hydrogen is twice the volume of what? Oxygen. And therefore this will be 10 centimeters what? Cubed. What does that mean? That even if in that gas cylinder they put there 20 centimeters cubed of hydrogen, not all of it did what? React. What does that mean? That according to our equation of reaction, it is only 10 that reacted. It means that the other 10 remained unreacted. Therefore, this would be our correct version. What does that mean? That the volume of hydrogen, the volume of water vapor will equal to the volume of hydrogen gas, which is what? Which is 10 centimeters cubed. Or it will equal to twice times the volume of what? Times the volume of what? Oxygen, which is what? Which is 2 times 5, giving us what? 10 centimeters cubed. This is where the logic, this is the logic I talked about. You have to twist your calculations so that they fit. Because if I was to start with this, it means that I would have forged for myself 10, which 10 I was not given. Yet it is true that even if 20 centimeters cubed of hydrogen were mixed with 5, not all the 20 did react. Therefore, it means that there was a volume of unreacted oxygen, unreacted what? Hydrogen. They may also ask for the volume of unreacted hydrogen, which is gotten by the one that was given to you minus the one that did what? React. What does that mean here? That volume of water vapor here will equal to the volume of reacted what? Hydrogen. Because not all the hydrogen that was put did react with oxygen. That is example 1 on Gay-Luskas's law. Let's look at example 2. Let me hope the viewers, you've copied that. Please copy that very fast. But in the exam, don't give us those two alternatives. Don't give us the two alternatives. Give us only one alternative, which you're sure. Okay. Example 2. Example 2. Ammonia gas decomposes according to the following equation. That is our ammonia gas. Remember, it is a reversible reaction, giving us what? Hydrogen plus nitrogen gas. One would wonder that all the gases you're giving us are diatomic. It is true, some of them are diatomic, but others are not diatomic. But these gases are diatomic at room temperature. So let us try to balance our equation. You have how many we have? We have 1 nitrogen atom. This side here we have 2 nitrogen atoms. Therefore, we multiply here with the what? With a 2. And when you multiply here with a 2, the nitrogen atoms have become 2. Even the other side, they have become 2. but it has affected the number of hydrogen atoms. Therefore, we also multiply here with the what? With the 3. Okay, that is the equation. But they're saying calculate the volume of nitrogen gas that was formed when 100 centimeters cubed of ammonia gas was decomposed. Okay? Okay? They're asking for the volume of nitrogen gas. And I remember I've been telling you students that once you get the few definitions in mole concept, whatever number that will come along, you will simply crush it because the definitions will tell it all. From our equation, what are we seeing? We are seeing that 2 moles of ammonia decompose to form how many moles? To form 3 moles of hydrogen, and how many? And 1 mole. And 1 mole of nitrogen gas. That is from our equation. If it had come in paper 2, please you write for us that. If it is in paper 1, because we don't show the working, we don't need it. We are only interested in the answer. So let me rub off this. Okay. From our equation, what are we seeing? We are seeing that. But remember we said from our law, the moles are equated to volume. Therefore, it means that if the 100 were decomposed, the 100 of ammonia were decomposed, it means that here you had 100 that you decomposed. Okay? 100 of ammonia. Therefore, what will the volume of? Let us start with maybe hydrogen. Volume of hydrogen that will be formed. Volume of hydrogen that will be formed, what are you seeing? You're seeing that from our equation, we are seeing that 2 moles give 3 moles plus what? Plus 1 mole of nitrogen. What does that mean? That the volume of hydrogen gas is bigger than the volume of what? Of ammonia. Therefore, it means that that will be 3. This is the mole that is there. 3 divided by the mole of ammonia. Therefore, it will be 3 over 2 times the volume of what? Times the volume of ammonia. Which is what? Which is 3 over 2 times 100. This is what? This is 1, this is 50, and this will give us what? 100 and what? Okay? What will be the volume of nitrogen? the volume of nitrogen will simply be, we use the same formula, which formula is volume of nitrogen will equal to what mole ratio? What mole is here? There is 1, which we don't write in chemistry. Therefore, it will be 1 divided by the mole that side, which is 1/2 times the volume of ammonia, which you're being given, which is 1 times 100. And this will give us what? And this will give us 50 centimeters cubed. And that is what you form. So you don't just write for us the answers. Please, you must show us the formula that you're going to use to calculate your answers. And that was example 2. There are cases whereby they ask you to calculate the volume of the resultant gas mixture. It means that what will, for example, let me just give this and I'll stop there on Gay-Lussa's law. For example, maybe you're given nitrogen monoxide. It reacted with oxygen to give us what? To give us nitrogen dioxide. That is what you're being given. You balance your equation. These are 2, but this side here there are how many? 3. Therefore, if I put a 2 here, it means that they have become 4, and I simply put here 2. There are cases whereby you're given a chemical equation only involving gases, and they're not asking for the unreacted gas. They're not asking for the volume of the gaseous product, but they're asking for what gases are going to remain there after the reaction has taken place. It means that in such a scenario, maybe what are you going to form after the reaction? You'll have the nitrogen dioxide gas, and in case you're given some of the volumes of either nitrogen monoxide or oxygen, maybe some of it was in excess. Therefore, the total volume of the resultant mixture will be the volume of the gaseous product formed plus the volume of the unreacted gas. In case one of the gases, its volume was given in excess. Those questions are also very common. Therefore, I'll leave you with numbers on molar gas volumes. Then I'll start on something very new, and that will mark the end of mole concept, and that is molarity. So I'll leave those numbers. Let me first introduce this. Oh, God. Okay. Let me introduce this briefly. Molarity. Not the morality, the one that you study in CRE, the one that comes from morals. This is different. This is from moles. Molarity is going to form part of your paper 3, part of your paper 4, if a number is to come on volumetric analysis, which is your practical paper. And remember, those numbers are compulsory. There are only 2 numbers, and they are compulsory. So what is molarity? I told you only the few definitions that are there in mole concept. Grasp them. When you grasp them, everything is going to be very, very fine. What is molarity? Molarity is the number of moles of a substance or a solute dissolved in 1 liter of a solution Molarity, number of moles of a substance dissolved in 1 liter of solution. Remember, 1 liter is equivalent to 1 decimeter cubed. It is also equivalent to 1,000 centimeters cubed. So when you're looking at molarity, please remember, if the question is to ask about molarity, define the molarity of the given solution. Remember this definition. Number of moles of a substance dissolved in 1 liter of a solution. How do we get the number of moles? The number of moles, remember we said the number of moles are gotten by getting the given mass over the relative molar mass or the relative formula mass of a given substance that has been given to you. Therefore, from our definition, we can also get the units for molarity. The units for molarity, we shall have 1. We can have our moles. Remember, we are saying moles, but per liter. Or, which we are going to abbreviate as moles per liter. Or, remember, we are saying that 1 liter is equivalent to 1 decimeter cubed. Therefore, it can also be moles per cubic decimeters. Which is also abbreviated as moles per cubic decimeters. So, when we meet next week, we shall throw more light. I'll throw more light on molarity, because I've told you in paper 3, paper 4, if a number is to come on volumetric analysis, this is what we shall basically look at, molarity. Before I wind up, let me give you the exercise I had prepared for you on Gay-Lussa's law. Our exercise, I'll only leave you with the 2 numbers. Number 1, okay, calculate the total volume of the resultant gas mixture. Then the other will be on molar gas volume. Calculate the volume of carbon calculate the volume of carbon dioxide gas evolved when when 4.6 grams of ethanol was completely burnt in oxygen. Okay, open brackets. It means that my volume, they're going to give you an instruction whether the volume of carbon dioxide should be at STP or at room temperature. Open brackets, 1 mole of a gas at room temperature occupies 24 liters, comma, carbon is 12, O is 16, and hydrogen is 1. Okay? Our dear viewers, time is not on our side, but I must be very grateful to Maryland High School. Secondly, to BBS and Savasajja Awangale. Thank you so much.
tweyanze ensonga bwe zityo bwe zitambudde olunaku olwaleero omusomera mu ddiiro lyo katulindirira ate senior 6 ku ssaawa zijja kubeera 9 ez'akawungeezi aba senior 6 bw'omugenda okuba nga ate nammwe mutuula mu kiraasi eyammwe. Maryland High School batuusaako ensonga zino, Green Hill Schools, Big Pen, kwoteeka bannaffe abankumba University wamu ne Kids Kingdom Schools ne amasomero ga Gombe Education Services. Bwe tutambula musomera mu ddiiro lyo buli lunaku wano ku BBS Telefine y'Obwakabaka bwa Buganda. Abasiniya ey'okuna tuddemu ate tusinkana olunaku olw'enkya n'ab'ekibiina eky'omusanvu ababa primary. Abasiniya ey'omukaaga mweteeketeeke ne siniya ey'okutaano ku ssaawa 9 tujja kuba nga ate tujja wammwe. Ssaabasajja Kabaka awangaale.
somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisulo eby'omulembe, science laboratory ssaako ne computer lab wamu ne.
She gives you her number, but your pen didn't work and the bus is gone. Get a pen you can rely on. Big Crystal, the long-lasting pen with perfect ink flow.
Wamune.
Green Hill Academy has high standards of learning and the teachers are very good.